So I have two cylinders, and I'm going to place a piston here. And I'm going to place another piston over here. Okay. And then what I'm going to do is I got to put some hydraulic fluid in here. Most hydraulic fluid is primarily red. You'll find some hydraulic systems use a purple power fluid. So the famous purple power fluid. Most hydraulic systems are somewhat red, sort of browny over time, but sort of a reddish color. I like the red color here. Okay, and what I'm going to do is I'm just going to put, rather than putting a lever on here to apply pressure, I'm just going to put a plate. Sort of like think of like a hydraulic plate, some type. Like if you were to put this under a car, I apply pressure here and it'll go up in this direction here. So let's say that my force applied in this particular instance here, I'm going to put 10 pounds. Put a 10-pound weight on here like that. And of course, that is a downward force that we're applying there. This will be an upward force, and we need to find out what value of force we can generate here. So there's some things that we're going to need to know first. Well, we're going to need to know the diameter of this. So we're going to say that the area, we could use the diameter and then convert it. We'll make this one easy. So I'm just going to say that the area here is just 1 square inch. So it makes it really easy. The area of this piston here, this piston is 1 square inch. So let's take a look at what's happening here. So let's get a proportionality triangle in here. And let's put our equation in here, and hopefully you remember the equation here. So I've got force in pounds. I have pressure in PSI, or pounds per square inch. And then, of course, I would have area, and that's going to be in square inches. Okay, so now we have that we can look at. So let's take a look. So solving for this, we would say, okay, well, pressure is equal to force divided by area, right? So we could say that our force is 10 pounds divided by my area of 1 inch square is going to equal 10 psi, 10 pounds per square inch, right? Simple enough. And we think about Pascal's principle, and Pascal's principle says that the force that is applied to the fluid is transferred to the fluid undiminished. So when I think about that term, I think undiminished, I go, okay. So if I have a value of work in must equal work out. I think in those terms. Okay. Well, what in fact is the work here? We know that the formula for work, and you should have done things similar to this in theory 1, force acting over a distance, right? So force times distance. And in this particular case, we're going to say that, well, our force we know is 10 pounds. And we know that the distance, I haven't put the distance in here, the distance is the stroke. So how far this will go down when I apply the pressure, because in a normal hydraulic system, it'll have a stroke distance. Okay, so we need to know what that is. So for this one, we're going to say that the stroke distance here is 5 inches. It's got a 5-inch stroke. Okay, then we go back to here and we go, okay, so my distance is 5 inch. So my value of work is going to be 10 pounds times 5 inches equals 50 inch pounds, because that's the unit that we're using, 50 inch pounds, 50 finch pounds, 50 finch pounds. I like finch pounds better. 50 inch pounds. That's the work that's being generated as a function of me placing 10 pounds of force. And it could be manual force. I can apply that manually down, or it can be a weight that I put on there and I apply 10 pounds of force. And we will get a value over here. So let's take a look at what this one is. So let's make this real easy and say that this area here for this piston is 5 times that of the other one. So area is going to equal 5 inches squared. Now, say, okay, well, I've got 5 square inches, and what do I know? What do I know? Well, let's see. I know that my force is equal to pressure times the area, right? So my force is going to be equal to pressure in PSI times my area. And I know we just calculated that I have, what, 10 pounds per square inch over here, don't I? I have 10 pounds per square inch, and my area on this one is 5 square inches. So I have 5 square inches there. So the result is that I have 50 pounds of what? Well, I have 50 pounds of force. So I have over here, I have 50 pounds of force in an upward direction. And you can think of that, like this. Well, I got 5 square inches here, right? So everywhere that fluid is being distributed undiminished throughout this machine, and it is applying 10 pounds per square inch. My area of that piston is 5 square inches, so I have a 5-fold increase in the amount of force. 10 pounds of force in, 50 pounds of force out. Now you may be saying to yourself, whoa, this doesn't make sense. The law of conservation of energy will not allow this to happen. I cannot apply 10 pounds of force and have 50 pounds of force here. It cannot happen because of the law of conservation of energy. Well, let's take a look at that. Let's take a look at that, because I would agree with you that just doesn't sound right, but something is actually happening here. So we said over here that work, oh, that's supposed to be an I. So we said over here that work in equals work out. And we have determined that we have 50 inch pounds of work, right? So we could, and if we look at our formula over here, we look at, say, work is equal to force times distance. So then I should be able to say that the distance is equal to work over force, right? So my distance or travel is equal to my work divided by my force. Agree with that? And if you were to put that into a triangle, right? If you were to put that into a triangle, we would put in, we'd say, based on this, we're saying work is equal to force times distance. So there's work, and it's equal to force times distance. So now we can visualize, well, okay, well, distance must be work over force, right? Distance is work over force. Okay, so if we subscribe to that, what is our work? Well, our work is equal to 50 inch pounds divided by my force, which is 50 pounds, equals how much travel? 1 inch travel. So the amount of work is the same, but because the fluid is